Hello everyone, so this is our second class or second live event on the subject of Python for scientific applications. As I told you in the first one, this we will give a step back in the sense that will present you fundamentals of the Python language in order so you can understand how the code will be used. If you're not familiar with programming languages of any kind, you will feel comfortable here. If you're already familiar with Python, I only advise you to pay attention to some details. And if you're not familiar with object-oriented programming, you could look for in any of the free courses you'll find on YouTube about that. But here I will suppose that you, like in the first event, you're a scientist or a physician or any person with a higher degree education that wants to use Python for a specific application. So I'll have a practical approach to what we are doing. So you already seen our Jupyter notebook that's installed along with Anaconda, the Anaconda distribution of Python. It comes with all the packages we use, where we will need in this series of events. So here we have lines of code or Markdown. That's the language for documentation and reporting on our code. So I'll start stating the very simple facts about variables. In some programming languages, you have to define variables. You have to say that these variables are of one type or another. If you have used databases of any kind, you have to say if something is a number or it is a text, it is a floating point, a decimal number, all these things together. My main purpose here is to explain that Python is a dynamically typed language, so you don't have to inform what type it is. It infers the type. The language infers the type along with your use of that language. So if I say A is a text, let's be simple, this is a text, it's using these signs, okay, or optionally this or the sign. So this is a text, and this is a very particular kind of variable that contains this text. It's in the memory of the computer as a text. If I wrote something like that, this is a integer number. Remember, I use Shift Enter to execute the cell and move it to the next one. I also have the option to press Run here. And to create new cells, I can create new cells, insert cell above, insert cell below. This is, for example, a floating point, a decimal number, a number with a representation of a decimal point. There is a precision associated with that. I will try to explain this later on when you're doing real calculations. Try to explain what that mean, what it means, and what it means machine precision in this context. Okay. So the first kind of type of object we say in modern programming language, the first kind of data variable that we have is the list. I mean, it's not the first, but it's the most standard in Python. So if I say something such as P and I use square brackets, as I told in a previous class, this is a list of numbers. Okay, it's very important to get used to how Python deals with lists, because all the data types that we see in the next and in the following event, we will see that many other kinds use the same approach that lists use in Python. Okay, so P is a list, and it can be indexed using square brackets as well. So P of 0 is the first element, P of 1 is the second element, and so on. There are some replacements, there are some types of indexing that are special. For example, -1 is the last one, and it's treated as if the list was circular, okay, as if it was circular. So P of -2 is 1 before the last, and P of -3 is 2 before the last. Okay. Yeah, and I can use something that's called slicing. Okay, slicing. It's when I use this sign of 2 points, and if I say 0, 4, it's a fraction of the list. It's a sublist. I say it's a sublist because it results another list. Okay, it results another list. I can even say it to another variable. I can even attribute it to another variable, as you can see. So what does that mean? It means I take the elements from the list, starting from the element in position 0 up to the element before position 4. It's not up to 4, it's up to 1 before position 4. Okay, this is so because of reasons that will use less -1, -2, +1 in your code if you use this version. So if I say something like that, it's up to 1 before the last. If I say nothing, if I let it empty, then it is something that you can say all of it. See, it's unto the last. So this is from the element in position 3 up to the last. If I leave it empty before the 2 points and say something like that, like this will be from the start up to the element before position 7. In this case, it means all of them. But if I say P from the start up to 6, from the start up to 5, and then you see it goes up to 1 before 5. 0, 1, 2, 3, 4. Okay, so this reasoning is very important when dealing with lists. It will save you lots of code, not only dealing with lists but dealing with other data types that are important in scientific computing. Okay, well, so a list is not a vector, right? It's not an array in the other language sense. We will see other data types that present this behavior of an array. What do I mean by that? An array is a kind of variable where all the elements is a collection of variables where all the elements are of the same type. Therefore, they occupy the same space in memory. So it makes addressing very easy and fast. But lists are not like that. I can have a list that contains completely different elements. I can have a list that contains a letter, a character. I can have a list that contains a text. I can have a number. I can have a floating point number. I can have another list inside of it. Okay? And this is all valid. So P of 0 is a character. P of -1 is a list, and since it is a list, it can be indexed too. P of -1 of 1, so it's 7. It's this number here. It's the last one in P, and the second index 1, because it starts from 0, is 7. Okay, so a list can be any kind, so because its elements can occupy different sizes and memory. Well, so this deals with the first few variables that we'll need in Python, and we will define all the types along with using all the functions that the language proposes to have. So it's important that you're going to use many mathematical functions. To use mathematical functions, you need to import them. You need to have them available by means of modules. In Python, that's some people call libraries or packages. Okay, so in Python you use modules, as I told you in the first class, from the word import. Okay, so import numpy, it's the most important package we're going to use. I've used it in the first event I presented here. In the first event I just gave a general impression on how the language works and how it's installed on your computer, or how can it be used using Google Colab. But here I'm going to start again to give new information, detail on the use of the language. So when I do that, and as I told you in the last event, as NP, so I gave a nickname, I give a synonym for numpy that can be used to access all the functions that this package has. Well, then first one I have used was to generate a sequence of numbers. So I can use a range that generates a sequence of numbers from a certain point with a certain with a certain size. It's inside numpy package, so I have to use np x. Then it generates a list of numbers from 0 to 5 up to 1 less than 5. Okay, so if I say something like this, you will see it's the same thing with an interval, with a step of 2. So 0, 2 and 4 because it's before 5. If I say something like 0.2, you're going to see an interval of 0.2, so 0, 0, 2, 0, 4 up to 4.8. That's 1 before 5. So a range creates a sequence of numbers from some start I have stated to another up to one before the another with an interval specified. I have used before a different function that's called linspace. It's very similar to the function that you find in MATLAB. So linspace, it creates a linearly spaced sequence of numbers, okay, where you specify not the step, but you specify the number of elements. So y in this case is 20 numbers starting from 6 exactly to from 2 exactly to 6, right? Here you have used that Python indexing way that you do not include the last number, you do up to 1 before that, and here you use that MATLAB syntax where you go up to this number. Also, this is specifies step and this is specifies size, or the number of elements. You have noticed also that this is not a list, okay? This is not a list. You have square brackets, but you have another definition, array. So in an array, it's a numpy array, an array defined inside this package is a list of numbers all of the same kind. So if this is a floating point, a decimal number, all of them are. If one is an integer, all must be integer. If one of them is promoted to a floating point, all of them must be. If one of them is a complex number, all of them must be. Okay, so this is an array. So it creates a contiguous space in memory because they are all the same size and they are addressed by the same name. However, they are indexed in language-wise, okay, in the same way as Python lists. So I can say 0 up to 6. I can say 0 up to 6 every 2, okay? It's also possible in lists as it is here. I can say 0 from the start up to 6, from the beginning, I mean from 1, and from position 2 up to 1 before the last. This indexing ways, they are all valid here using numpy arrays, okay? Let me see if someone has asked any question. Questions up to now. Well, what else can we say here? You have understand how lists works and how Python array work and how the lists are indexed. This is very important. You go one step further and you're going to define functions and define control flow control structures. They are common to all computer languages. For example, if you use this a lot. How does it work if in Python? There is if and a condition, 2 points, and you have to state the comments to write here the code that you want to be executed if condition is true, if condition is valid. So there is condition and code. What does that mean? So in Python there is a kind of variable that is the Boolean variable, the variable that can be true or false, and it's usually generated with logic operators. For example, I will create a different cell. So you see 3 greater than 5 is an operation like addition, like subtraction, and it results false. Okay, 6 greater than 5 results true. So if I can do tests like that with lists. For example, 3, 4, 5. greater than 4. This is not supported, but I can do with another list, and they are all false because one of them was false. Okay, because I have used Python lists to do logic operation, greater than or equal. If I do the same with Python arrays, I can create a Python array using lists or a list of lists if they are all the same size, okay, by using the command array inside the package numpy. So array is a constructor for the object array. In this sense, the result is also an array. Is an array with false, true, and true, because it results. It performs the operation for all the elements in the array. Of course, this only makes sense if the arrays compared are of equal size. If I try to compare something like this, that will be a mistake. They must have the same size, must have the same dimensions. Okay. So NumPy arrays, of course, I can create NumPy arrays using lists, but if they have more than one dimension, they must agree with size, because they will be interpreted as matrices or as tensors in a general way. I mean, a tensor is a multi-dimensional structure, mathematical structure, like the tensor of tension, like the tensor of space-time in physics. So if I create an array from lists and a list of lists, they must be coherent in size. So there will be 3 columns and 3 lines. Then P, you see, is an array that will work as a matrix. In fact, in Python, if I create not array, with a very similar structure, then I have P and I have A. That's 2 arrays. Okay, there is an operator at. Okay, P at A is in Python the matrix product. If you do not remember that, the matrix product is the sum of the products of elements from a row in the first matrix and a column in the second matrix. So if P, this is from even high school, I think, right? This line multiplied by this first column and all the elements added. So it's 1 times 4 plus 2 times 1 plus 3 times 0. This creates the first element in the first row and in the first column. So if I want to create the ij element from the ith element in the row, the ith row, and the jth column, I will use the ith row from the first and the jth column from the second. So the result, it will be from second line, third column will be second line here, third column here will be 4 times 6 plus 5 times 3 plus 6 times 7. Okay, and you will see that if I do this operand, I'll use this operand. So this is an abbreviation. In Python 2 this was not possible. If I wanted a matrix product, I would have to use a function inside NumPy package. So this makes things easier in code, because a matrix product are very common. Products are very common to define statistical operations, graphical operations, and so on. If I use times operator, you will see a completely different thing. You will see a product element by element, an element-wise product, right? So it's 1 times 4, that's 4. 2 times 5, that's 10. 1 by 1. Of course, this operation is only possible, is only meaningful when you have 2 matrices with the same dimensions, and this operation, the matrix product operation, it's only reasonable, it's only meaningful when the number of columns in the first matrix equals the number of rows in the second matrix. Okay, so that's definitions that you maybe remember from some course you made in your life. Okay, Continuing, I can have dimensions of lists using the function len. It's from Python, it's not from NumPy. So len of p is 5 because p is a list of 5 elements. However, length of capital P is 3. Why? Because in a sense, if I try to, P is a matrix, is an array with 2 dimensions. You see, there are 3 lines stacked, vertically stacked. But if you see as a list of lists, you see there is a list with 3 elements where each element has its own list. Is a list with 3 elements. So the size of the length of this variable p is 3 because of that. Of course, if I say p of 0 is 3 too, because that's the first line, the first row, and length p of 1. Okay? But there is another comment that's more meaningful for this for matrices and NumPy arrays. There is shape. You see, it's not a function because I have not used parentheses. I use the variable dot shape. So it's an attribute. It's an internal variable of this object p. It's a different thing, you know. As I told you, you can study object-oriented programming in another course. I can make an event about that if you say you need so. So p dot shape give me the dimensions. So it's a matrix with 3 rows and 3 columns, if I say it as a matrix, or if I say as a tensor, I can have more dimensions. I can have 3, 4, any dimensions here. They will be sequenced informed by this command p dot shape. The same for a. Okay. If I have a different matrix, I will define a again with just 2 columns. Executed, shift enter. If I do a shape, you see there's 3 lines, 2 columns, 3 rows, 2 columns. Okay. So basic info. Of course, if I do that, p times a is no longer possible. Okay, and p at a, that's a matrix product, that is possible because the number of columns in the first matrix equals the number of rows in the second matrix, because that's what makes a matrix product valid. Everything all right up to now? Okay, thank you. Going on from this very basic operations in Python, we can use if, as I told you, the control structure. If a condition is true or false, I can try to use it over a matrix, as I was saying to you, but I cannot do it anymore because they are not the same size. Okay, but I can test a condition. For example, if the first element of p, you see, I can use now a different way of indexing. p 0 0 is true. Of print p. What this code is performing. If p is a number, I'll print it, but it's always a number. I'll create a logical condition. If p first line, first row is positive, is greater than 0, I will print it. If I use a comma, it's the same. Okay, so for Python arrays, I can use a comma to index several dimensions, given the impression that it is an object, not an object of an object. Okay, it's not a list of lists. In fact, it's a different object with different more properties. That what makes a Python array. So I can use comma as an abbreviation. So this is how if works. If this condition is true, I will execute a sequence of codes that I write here. It's, you know, it's a common structure in our language, but if you have never used Python, you have to take notice of the following fact, that it's not just important to make correct indentation of your code, it's obligatory. You must use print. Let me say I'll print p and then I'll print a. If P in this position is larger than A on this position. We print nothing, okay? I'll print contrary-wise. You see? So I print in this order A and then P because this was not true. This was false. As I was telling you, I must use the correct indentation all times. I cannot choose. It's not something that you do just to make your code look nicer. It's something that states the exact scope of if and else in this case. You know, in C language or in Java language, you have curly brackets to define scope. So you write here something like curly bracket starting and another curly bracket ending your section of code to be executed in the case that these were true, and another section of code. But here they are not symbols like that. You use space. The language uses space to define the scope of things, of everything, not just if else. So you must use consistent spacing in your code all the time. It forces you to organize. So another control structure is flow control structure is while, which is very similar to if, okay? But there is a condition that must be true. Condition, so dots, and then the code that is to be repeated. And the fact is, this code will be repeated as many times needed, as long as this condition is still true. So if I say A equals 0, then I say while A is smaller than 10, 2 points, A will be increased A plus 1, and print A. Of course, this will print all the numbers from 1 to 10 because I have printed and increased the number by 1. Okay, there is the old school abbreviation for the increase of a number, for the adding in the same variable. It's plus equal. Okay, so you have understood how it works. While probably you already know that from another language, so this is how it works here in Python. Again, you must use consistent spacing in your code, always. If you want to have several conditions, there is no switch statement in Python like there is in the C language. You must have several if clauses. And when you want to combine several if clauses, it is possible by using an abbreviation called Elif. So Elif and another condition. Well, if P11 is greater than 0, then print positive P11. So I can put as many conditions as I want. I don't. Maybe it's limited to 255. I don't know, but as many as I want. So I create several conditions, and else is optional. Is the last one, the one that will be executed if none of them is true. Okay, so those are make cases. I can combine, of course, while and if. And another flow control structure that you will need is for. And for is very particular in Python because it carries lots of meaning from the object-orienting part of the language. And I'll try to explain this now. So, for example, for was made to work usually over a list. For example, for v in p. This is how it's wrote. You have a variable, usually a variable that I am defining here. This variable is the iterator, the variable that will go through a certain values. And this is a list of values. I will start with a list, but it can be other kinds of objects. Then 2 dots, and then the code that will be sequentially executed. So I will execute this portion of code with every time I execute, I mean in every iteration, I will use a different value for v. Each time the variable v will be one of the values in p. So that's why the English statement here, for v in p. So this is a belonging operator. V belongs to P, so I'll try to execute a certain code making V every one of the elements from the set, P. Right, so if I just print V, you see all the elements of P were printed in the order they appear. So, but in the language, in Python language, you not only have to be a list, it can be any object that's called in Python iterable. You can even create your own objects that are iterable. You have to define what means the action of going to the next value. So these are objects that define an internal method called next. If you're going to see what's in Jupyter, you have the option of pressing a variable, dot and tab. You will see the methods that are available inside this object, just because it is an object of this kind. In this case, it's a list, so you can use all those functions. Okay, so P is a Python array. You will see there are many methods that can be used over it. If you don't know, you can just use it or look for in the documentation. So P non-zero, P ending, P n bytes, P min, P max. So the average, for example, of the element in P is here. Well, so Python defines several objects to be iterable, and NumPy package arrays also defines. So for in capital P, let me see, print you see he's printing every one of the lines of P. So when I iterate over a Python array, it iterates over the outermost dimension. I mean, in this case, the rows, since I've seen this as a matrix. So it will be this, and then this, and then that. Since every one of them is also a Python array, it can be iterated too. So for C in A, I can iterate over it again. And then when I try to print C, for every C in the elements of air, I have printed all the elements of it. Print is a function that by default jumps a line, creates a new line. If I want to change this behavior, you can just look in the documentation. You change the parameter end. So if I print with a space and a dot every time I go through a certain element, and then when I end the most internal for, I'll write here the code, which means I'm out of the scope of this for, but still inside of the scope of this loop, this for loop, and I'll print an end of line here. I print empty, it means printing an end of line, because print by default prints an end of line. So I have used the space and then a comma. I'll change the behavior of that to this. Okay, so I have print P, and I have seen how it works, the for loop. You see for loop, so you create a variable that iterates over a list, or in the most general way, an iterable element. And I here used another for inside of that to iterate over all the elements inside every row from the Python array P. Okay, so this is how this three flow control structures are used. You won't need much more than that as flow control structures are concerned. I will just state another one that sometimes you will see, but I advise you not to use as long as you are an advanced user of Python. Okay, it's the try construct in Python. Very problematic, I would say. So how it works, it's very similar to the try catch or in Java, or it's try except in Python. And it looks for an exception, which means an error that's not well defined, or that's defined, for example, when you try to open a file and this file does not exist, and you don't have the authority to create a new file. So it works like that. Just like try, two dots, and then a code that will be executed if everything is alright. If everything is alright, this code is executed, and then you have except. And except works like that. It's the code that is executed if some problem occurs inside this execution of code. Okay, you've seen before I have tried to do an operation with matrices that was not valid. Things like that can happen. You see, I tried to compare with a logic operator two matrices that were of different sizes or different shapes, and this was not possible. So let's use this as an example. So I have a matrix NP array, I'll fill with numbers just as a test. A matrix B, I need commas, okay, and C. Now give this the same dimensions of the first one. So I have three matrices. You will see A, shift enter. This is another matrix, and this is another matrix. Okay, you already seen that C times A is a valid operation, because the number of columns in A equals the number of rows, the number of columns in C equals the number of rows in A. But A times A at C is not valid. Shapes 3 and 2 are not possible. If I do C at A is not possible as well. But C times A, well, that's possible, because that's the product element-wise. One element of C, one element of A, and they have the same dimensions. There is another operation that's called the transposition. If I do C dot transpose, okay, that's inverting rows and columns, then I can do this operation, because C transpose has dimensions 2 and 3, and dimensions of A are 3 and 2. Okay, so operations like that can result in mistakes, can result in errors. So imagine I'm trying something. I'm trying to do D equals C at A, and if that does not work, except I'll do that D is transpose at A. So if I'm not sure what's going to happen, if there will be a mistake, the mistake occurred, and I don't know which one he executed. But if that resulted in an error, an exception, the exception is consumed, the exception is obliterated in the code. You haven't seen any error message. It hides the error message because it is expected that they are treated here. It is expected they are treated here, and that's what happened here. So if I try to, for example, print, what happened after my attempt of executing this code? You see, there were no success message printed, because this was not executed up to the end, because this comment before the function print be executed was not executed. It resulted in an exception, and the exception ends the code and jumps to the except portion of the try except statement in Python. If I had used print function here, alternative success. How sympathetic. And D is valid. This is a valid matrix. Okay. So these are all the flow control structures that you will need in Python. There is if, while, for, and in some cases try except. Some cases I would say that you see written somewhere, or some code that you have to change, because I do not advise you to use try except conditions unless you're very advanced in your Python programming. Why do I say that? Because since try except hides error messages, you will be every time tempted to use all the time to hide error messages, and sometimes error messages are important to know what's happening. So be careful. Only treat mistakes, errors, exceptions when you know what you're treating, when you know exactly what kind of exception this portion of code will render, will produce. Okay, so that's my advice. You see, in this event I have presented you the very basic code for Python. I have gave a step back from our first event to explain you how it works and what is the NumPy array. That's the main object, the most frequent object we will use here in our Python program for scientific applications. So if you understood all that, you're good to go. You can now understand our applications. Then I will start doing simple calculations, statistic calculations, to start things in a very useful way. On the next event, Thursday, I'll give a hint of how to make ANOVAs and t-tests using Python, using these codes, and I will use these flow control structures all the time, and I will start reading files. And then after statistics, we'll use linear operations and 2D and 3D graphics. Okay, so but I need, we all need that these basic operations are completely clear, so I can move on. Okay, if you have any questions, you can leave here at the comment section, and thank you very much for your attention. Goodbye, see you next time.